Welcome, my dear students. We are going to study 18 electron rule. This rule is also called as inert gas rule or rare gas rule, or it is also called a 9 orbital rule. It is useful in predicting stability of organometallic compounds, metal carbonyls and complexes, that is the coordination compounds. An alternative and more general statement for effective atomic number rule is the 18 electron rule proposed by Sedgwick in 1927 to explain the stability of complexes. The rule is based on the fact that the transition metal consists of 9 valence orbitals, 1s, 3p, 5d orbitals, which collectively can be accommodated 18 electrons as either bonding or non-bonding electron pairs. 18 electron rule states that the central atom or ion of a complex will accept electron pairs from ligands till the total number of electrons in its valence shell orbitals n-1d, ns, np is 18. When a metal complex has 18 valence electrons, it is said to have achieved the same electron configuration as the noble gas in the respective period. Such metal complexes with 18 electrons exhibits high stability. 18 electrons rule is more useful in the context of the organometallics. 18 electrons rule can be used to predict the molecular formulae of some complex compounds in a particular metal carbonyls. In predicting formula of mononuclear carbonyls and formation of binuclear carbonyls. The donation of an electron pair from ligands to metal, sigma bond form, and donation of electron pair from metal to ligand, pi bond formation. The predicting the formula of mononuclear carbonyls, we consider the metal carbonyls, for example, tetracarbonyl nickel. The metal atom and its atomic number, metal atom nickel, it has atomic number 28. Outer electronic configuration 3d10, 3d8, 4s2 means there is 10 electrons. Electrons donated by ligands 2 into 4. Each carbonyl ligand donates 2 electrons, so 2 into 4 is equal to 8. The total number of electrons on metal atom in the complex is 10 plus 8 is equal to 18. The pentacarbonyl iron, the iron 26, the electronic configuration outermost, that is 3d6 4s2, the 8 electrons, the 2 into 5 ligands donate 2 electron each, then 2 into 5 is equal to 10, 8 plus 10 is equal to 18. The metal carbonyl, another example, that is a hexacarbonyl, chromium 24, 3d5 4s1 is equal to 6 electrons. The 2 into 6 is equal to 12, 6 plus 12 is equal to 18. On the basis of 18 electron rule, the formation of nuclear carbons by transition metals with the atomic number in the table given above. Another example, ethylene iron carbonyl, ethylene tetracarbonyl iron, the iron Fe26, the electronic configuration outermost 3d6 4s2, electrons 8 electrons involved in the of the iron in a bonding, Fe 8 electrons, then the 4 carbonyl groups, so 4 into 2 gives the 8 electrons, then the 2 electrons that is the from the ethylene, that is the pi pair, 1 pi pair electron, that gives the 2 electrons to 8 plus 2, the 10, then 8 plus 10 is equal to 18. Another, that is the butadiene tricarbonyl iron. The butadiene that can has the 2 pi pairs, that is the 4 electrons. The iron 26, the 3d6 4s2 is equal to 8 electrons. Then the 2 into 3 carbonyl ligands donate the 2 electrons. So 3 into 2 is equal to 6, and the 4 electrons from the butadiene. So 6 plus 4 is equal to 10, and 8 electrons of iron. So 8 plus 8 is equal to 18. The formation of binuclear carbonyls having metal atoms with the odd atomic number can also be explained on the basis of 18 electron rule. The cobalt twice carbonyl 8 means there is a dicobalt. The cobalt is that is a metal covalent bond. The octacarbonyl cobalt, the one cobalt is attached to 4 carbonyl groups, and there is a link between cobalt and cobalt. Atomic number of cobalt is 27. Electronic configuration of 27 cobalt is 3d7 4s2. The two cobalt will make available, that is a 2 into 9, 18 electron. Then the 8 carbonyl will donate 2 into 8, 16 electrons. Cobalt bond 2 electrons. So total electrons 18 plus 16 plus 2 is equal to 36. Means for 2 cobalt electrons are there 36 electrons. The cobalt bond, that is formed by the dimerization process. The cobalt in which there is undergoes the dimerization, and there is a formation of the metal covalent bond. In complex there is a dimerization. Hence for the 1 cobalt electrons will be 36 divided by 2 is equal to 18 electrons. In manganese carbonyl, Mn2CO10 decacarbonyl manganese 25 Mn is equal to 3d5 4s2. 2 manganese 2 into 7 is equal to 14 electrons. Outermost electron configuration in which the manganese has 5 plus 2 means 3d5 4s2, 5 plus 2 7 electrons, and 2 manganese Mn bond covalent bond. So 2 into 7 is equal to 40 electrons, 14 electrons. There is a 7 electrons for each manganese. 2 manganese 2 into 7, 7 into 2 is equal to 14 electrons. 10 carbonyl ligands 2 into 10 is equal to 20 electrons. Manganese bond 2 electrons, 2 give 2 electrons, means there is a 14 electron, 20 electrons and 2 electrons. There is a total is sum, that is the 36 electrons. Thus 2 manganese have 36 electrons, and it is also the manganese complex with carbonyl ligands formation. There is a undergoes the dimerization, and there is a formation of Mn covalent bond. The 2 manganese have 36 electrons. For 1 manganese it has 36 divided by 2 is equal to 18 electron. It should be noted that the 18 electron rule is specifically observed when the metal as well as the ligands have pi bonding orbitals, and the metal has more than half filled the orbitals in its configuration. This rule is, however, not without expansion. For example, in hexacarbonyl vanadium, the number of electrons in a valence shell is 17 and not 18, but it is a stable complex. Vanadium 23, electronic configuration 3d3 4s2. Then total electrons in vanadium in outermost shell 5 electrons. Then carbonyl 6. Then each carbonyl ligands donates 2 electrons. Then 2 into 6 is equal to 12. Means 5 plus 12 is equal to 17 electrons. Means there is a this 18 electron not followed by the hexacarbonyl vanadium. The valence shell of that is a 17, not 18, but this complex is a stable one. Thank you.